Will solar power help us to fight climate change? Are you concerned about our planet? Do you know why man is causing it to change? Do you believe that we need to find a renewable source of energy? Well, I do, and so should you. We cannot just go on using fossil fuels that will eventually run out. Before they do, we may have reached a point in the Earth's history which there's no turning back. This week's conference in Copenhagen involves many of the politicians of the world, and if they get it wrong, we're in big trouble. Scientists tell us that our planet is getting warmer. We can see from this graph since 1975, the land and the ocean have been considerably warmer than at a similar time 100 years ago. This is not unusual. The Earth has warmed up and cooled down over a period of time before, but every time the Earth warms up, carbon dioxide levels increase too. The problem is the concentrations of carbon dioxide are higher now than ever. Had those deduced from the ice core data going back over the last 800,000 years. And it's getting worse. From 1990 to 1999, carbon dioxide emissions were increasing by 1.3% per year, and now it's goes to 3.4% a year. All to do with fossil fuel burning for power and transportation since the beginning of the Industrial Revolution. These graphs show us how China is the largest producer of man-made carbon dioxide at 21% of the world's emissions. They're just ahead of the United States, who produce 20%, and one long way ahead of the United Kingdom, who only produce 2%. The difference is that China emits most of its carbon dioxide by producing power, whereas the United States and the United Kingdom, a large proportion is due to transport. So, is solar power the answer? Well, every home can have solar panels on the roof with domestic hot water, and there are lots of commercial solar units available. This picture shows the new B101 solar thermal power plant. It is the largest installation storing renewable energy, apart from no storing hydroelectric power. It is unique that it uses molten salts to store the energy. This means it can run a steam turbine for 7.5 hours after dark. Also, because the energy is stored, it is cheaper to run than any other solar power plant. Another way to save emissions is solar transport. These pictures show Tokyo Challenger. It has more than 2,000 solar cells running over the surface of a 3-wheeled vehicle. It won this year's Australian Global Green Challenge. The solar cells were developed by Sharp and have 35.8% conversion efficiency, which is higher than any other cells. Sharp achieved these super cells by replacing the bottom germanium layer with a composite IgA, which absorbs most of the available sunlight. This meant the cells had an output of 1.8 kilowatts rather than 1.2 kilowatts produced by the conventional silicon cells. This meant the car could travel at 100 kilometers per hour as opposed to 86 kilometers per hour with normal silicon cells. So where was solar plane? Solar Challenger was the first piloted solar aircraft with enough energy to climb and stay up. In 1981 it flew 262 kilometers from Paris to London and took 5 hours 22 minutes. Much longer than the average 1-hour flight by conventional aircraft. Solar flying is challenging as you need to get above the clouds to be able to get the sunlight, but the more power is needed in the thinner atmosphere. The next challenge is to go around the world. The new solar impulse plane shown here in this picture has been developed in Switzerland. It has a 63-metre wingspan similar to a jumbo jet to accommodate the solar panels. It will take 36 hours to go around the world, so it will require solar power to be stored, as the plane will have to fly in the dark. These vehicles may seem very futuristic, but technology is already there, and hopefully we'll be able to drive in cars like these and fly solar planes very soon. If not, we may not be able to avoid more storms, sea level rises, melting glaciers, and loss of habitat. Thank you, and I'll leave you with a list of references.